About the difference between the two-stroke engine and four-stroke engine is that the two-stroke engine we basically get in a two-stroke engine we basically get the combination of the stroke, like suction plus we get the exhaust, and the compression plus the power stroke. And in a particular four-stroke engine we basically get the individual stroke. In a two-stroke engine, we get the twice in power, but in a particular four-stroke engine we basically get the single power. But as we get the twice power, but what actually happened, the mechanical efficiency, the thermal efficiency, the like volumetric efficiency of the two-stroke engine is less. And here the thermal efficiency, mechanical efficiency, the volumetric efficiency is the more actually the four-stroke engine. And two-stroke engine, the fuel consumption of the two-stroke engine is actually the more if I compare to the four-stroke engine. So the fuel consumption is more, and the four-stroke engine actually fuel consumption is less. And if I talk about the two-stroke engine, there have the noise issue that is known as a knocking problem. As the you see the power stroke, it generates the twice power. So because of that, what actually happened? As you see, it basically generates the twice power. So because of that, they have a knocking tendency. And but in a four-stroke engine, we do not have that type of knocking tendency we observe. So here we observe the knocking tendency, but in a four-stroke engine, we do not observe any kind of knocking tendency. And the fuel consumption, it is more. Simultaneously, the lubricating consumption in a two-stroke engine is actually the more. But the lubricating oil consumption in a four-stroke engine is actually the less. In a two-stroke engine, actually the less smoke is produced. Simultaneously, the four-stroke engine is the two-stroke engine, the more smoke, exhaust smoke will be produced. But in a four-stroke engine, the less smoke will be produced. So this is basically the two-stroke engine and the four-stroke engine. And now we basically talk on the petrol engine and the diesel engine. So in this particular in this particular differentiation, we basically see the petrol engine, that is also known as a SI engine or the carburetor engine, and simultaneously the diesel engine or the CI engine or the FI engine. So in a particular, the petrol engine is basically run on, it is actually the run on the Otto cycle. But the diesel engine actually run on the diesel cycle. But nowadays we basically run our diesel engine, the diesel vehicle, by the dual cycle. Why? It is very big question. Why? We discuss it in a later. And a compression ratio in a particular the petrol engine, the compression ratio, it is actually the less if I compare to the diesel engine. The compression ratio petrol engine is belong to the up to 6 to 10 bar, and it is belong to, if I diesel engine, it will be belong to 35 bar, and a dual engine it will be the 20 to 25 bar. And in a particular, for the combustion, here we basically use the spark plug, and here basically use the fuel injector. And the initial fuel consumption is less and no starting problem. Initial fuel consumption, when we start our vehicle, like petrol engine, the working medium, the petrol engine means the vehicle which is run on the petrol. That particular vehicle, the initial fuel consumption is less, or initial fuel consumption means when you just start your vehicle, that time the fuel consumption is less and there will be no starting problem. So during one kick it will be start. But in a particular diesel engine, initial fuel consumption is high and they have a starting problem. So why it is high, initial fuel consumption, why it is high, and why they have a starting problem, so you see here the compression ratio in the diesel engine, it is actually the very high. So because high means 35 bar, it is belong to 35 bar. So with that the high so that it actually compressed the air. So but in the initial time, what actually happened, the mean effective pressure of the piston, and the pumping pressure of the piston, it will be the very less. So because of that, the piston is not the compressed very well to that particular air. Because of that, initial fuel consumption, it will be very high. And so this is the one reason. and the starting problem also there. And as you see the as there have a no starting problem, so for that particular the mean effective pressure, pumping pressure, initially it will be very good, but in a particular diesel engine the mean effective pressure, then the pumping power, it will be the very less initially. So because of that, what actually happened, the scavenging problem, and due to the high compression ratio, they have a like auto ignition problem, and simultaneously as the auto ignition will be happen, then simultaneously the knocking tendency, it will be generate. And if I talk about the carburetor engine, the carburetor in engine, the main function of the carburetor is basically it is basically the the carburetor is basically a particular place which basically combine the air with a particular the fuel. So it basically then supply this air plus fuel, that is known as the charge, this charge into the particular the engine cylinder, which is further controlled to the throttle valve. How this throttle valve will be operate, and how this thing will be operate, I talk in the coming videos. But if the carburetor engine actually the manually operated, means mechanically operated, so it actually need frequent maintenance. But FI system engine actually it controlled by the electronic control unit and the sensor, so because of that it does not need a frequent maintenance. And carburetor engine, the fuel consumption rate in a carburetor engine is quite high if I compare to the FI system engine. So these are the basically difference. So as you see here, so in this particular diagram you see the how the carburetor will be operated. So it is basically the fuel tank. So full the fuel tank, the fuel will be came into the carburetor, and from the air filter air will be came into the carburetor. Both will be mixed and prepare the air fuel mixture. So this air fuel mixture actually called, the technical term of the air fuel mixture is basically known as a the charge. So this air fuel mixture is called the charge. So in this, actually the carburetor itself will look like a venturi pipe. All right. So air will be came through in this particular opening. Then so air in, and here I have a particular orifice which is further connected to the fuel tank. So in this particular valve, the fuel particle supplied. So this fuel particle is actually mixed with this particular air, and they prepare the air fuel mixture. And here I have a particular the valve, that is, this valve is basically known the throttle valve. The throttle valve, there is further connected this throttle valve. This throttle valve is further connected to the sleeve of the governor. When the governor is rotated, that time the sleeve is move upward direction. When the sleeve is upward, that time the throttle valve will be get open. The throttle valve getting leaned, okay, open. So that time actually engine supply the more air fuel mixed, more air fuel ratio into the engine cylinder. So this is how it will be operated. And the governor, this particular the speed of the governor, it is depend upon the acceleration, what type of acceleration you provide. So according to the fluctuation of the load and the speed of that particular engine, the air fuel ratio will be sent into the engine cylinder. So this is the phenomenon. Waiting for the next video. Till now, thank you.